We want to find the equation of the tangent to the curve, y equals log x squared, at the point where x is equal to e. So y is the natural log, the log to the base e, of x squared. And using our knowledge of logs, we can rewrite this as 2 log x. We want the point where x is equal to e, so y is equal to 2 log e. Remember, ln is the log to the base e, so we have log to the base e of e. In general, we know that log to the base a of a is equal to 1. So log to the base e of e must be equal to 1. If ln e is equal to 1, this gives us y equals 2. So the point on the curve at which we are interested is the point E, 2. We also need the gradient of the curve at this point. So we have y as the log of x squared, and we need to differentiate. We need to use the chain rule. The outside function is ln. If we differentiate ln x, we get 1 over x. So we start here with 1 over x squared, treating the inside function as if it's just x. But we then have to multiply by the differential of the inside function, which is 2x. 1x will cancel, leaving us with 2 over x. So dy dx is 2 over x. We're interested in the value of this at the point where x is equal to e. So the gradient is 2 over e. We now want to find the tangent. A tangent is a straight line, so we can use y equals mx plus c. This point lies on the tangent, so the x and y values here must satisfy the equation of the line. We also know the gradient. Substituting in enables us to find the value of c. So we substitute the values we have into the equation. The e's will cancel, and so 2 is equal to 2 plus c, telling us that c is equal to 0. The equation of the tangent then is y is equal to 2 over e, x.